Okay, hello everyone. This tutorial is a continuation from the previous example discussed in the classroom. That was the very basic case of uh, a stock and flow relationship based on the potential work rate, which is basically the rate of flow that enables us to transform the work, which was the task that we were given, into the work done. So, in the previous example, if you remember, we only had two stocks and one flow variable, um, and we only had three dynamic variables. Again, please note that for this case, we're keeping the values of these variables constant. So again, these can be treated as parameters as they stay the same throughout the model um, running time. So for the sake of completing this example, we have now modified this example to include embellishments. Uh, in terms of embellishing this model, we added one more stock variable and one two more dynamic variables and one flow. Again, when I say that dynamic variable, it is because in the palette you see that we are going to select the variable that gives us this feature that enables it to be treated as a dynamic variable. So please, I keep saying that, but that's a very important point. So again, coming back here, the first step here is to recognize how this initial model was transformed into this kind of model, and that is basically by assuming that for a work to be completed, uh, it's not only the potential work rate that enables the conversion of work to do from work to do to work done. There's also the issue of quality. That way, the amount of tasks we do is subject to this quality variable, where if there is a perfect quality, which is one, this is a dimensionless variable, by the way. So if there is a perfect quality one, and we should expect no rework. And if the quality keeps decreasing, then we should be expecting a certain amount of rework that needs to be fed back into the work that these set of workers have to complete throughout the simulation time. So how do we start? I will keep this model here and try to individually uh, input values for these variables. I'll do it right next to this model here. So this is our window. Basically, this is where we work. We do our thing. I will work outside of this box just so that I don't confuse what's already here with with uh, with with what we're going to modify now. So we'll go over the input variables. So I'll quickly drag it here. So the model setup is in a way that the previous variables, quality, number of workers, potential work rate, and initial productivity stay the same. Their relationship also stays the same. The additional thing that we have here is the rework discovery, which is the undiscovered rework over time to discover rework. So the undiscovered rework um, is the stock value that we have. So that's basically depending on how much rework is generated and how much rework is discovered. So whatever rework that's generated, um, will then need to be discovered and then performed by these group of workers based on the amount of rate that they do their work, right? So, for example, if they do 15 tasks today and not today because our time is in a month, uh, the simulation time that is being uh, that is performing the model is month. But for the sake of argument, say uh, if the group of workers are completing 15 tasks in time one, and then they come, say for example, the next day, um, and they want to complete the next set of tasks because they have a rework carried over from the previous time step. What happens is the amount of work that is deemed as incomplete and to be reworked will be added into the amount of work to do for the following day, in this case month. So this is the work to do. So we have uh, rework discovery, rework generation, and a work accomplishment. So this work to do is initially 100, so they're supposed to do 100 tasks. That's the unit, and that work will keep being in a way chopped off so that if you see it here, it also goes here and it also goes here. In a perfect world, if quality is 1, this work to do will just go here, and we'll have the same um, model results as we see here because there's no change in the system. But now because there is a leak, if you consider it as a leak, some of the work will leak here, so we have to kind of take it back here and keep working. So interesting thing is if the quality is less, what you could probably expect is the more you work, the more it's leaking, right? So the more you work, the more you have undiscovered rework, and the more you keep having to work that set of the rework set of tasks again and again. So enough about that. The rest of the variables this is basically a formula. You don't need to worry about this. For now, you're given as the feasible work rate. That's the work rate that these people are are completing. Um, I apologize, but when I modified it, I should also modify this to be potential work rate because that is the work rate that they have. And as you can see, the potential work rate is in a way affecting how much of the work that they do and complete it, and how much of the work uh, that gets into the rework. So here you have potential work rate and 1 minus quality. So if you have quality to be perfect, which is 1, then you will have this side of the equation to be 0, so you don't need to generate any rework. And time to discover rework is for now 4 months. So when they find out they have to do the some amount of the work that they do again is after 4 months. In this case, after 4 time steps. So here, uh, another example could be if the rule is so that whatever assignment that you you give back to your instructor, if you have, say for example, out of the 10 questions you have 6 of them right and then 4 of them wrong, the only way you can find out is after you do it and you take it back to your teacher and he grades it. Maybe it takes a couple of days. So after 2 days, you'll find out that you still have 4 wrong answers. So he gives it back to you and he will tell you, do them again. And then you do them again. Um, and out of the 4, maybe you get 2 of them right, and then you keep coming back to you until you finish the task. So that's how the whole system in a way goes. uh, Work accomplishment rate, again, I can compare it here, is potential work rate and is a function of potential work rate and quality. So uh, potential work rate and quality. Let's go back to the model and put these relationships into our model, right? So let's go back here. So for the sake of presentation, what I'm going to do is the relationships between these variables have already been entered here. So I'll just keep dragging and dropping variables, stocks and flows next to this diagram so that we can see how this is developed. So basically, I'm just gonna start working with this one now. Uh, okay, I think the best way to do this is to at least start with the model here. Start as a new model, and then when the time comes um, to develop this, we can develop it next to this window. So what we do is we do a new model, and this is another feature set of features that AnyLogic provides if you want to do agent-based modeling or even discrete event modeling on other on a yeah on a different set of problems. Sorry. So let's start a new model here. Uh, Model name, we can say assignment, and please do not put a space here because it will create problems for the Java function. Assignment, can say question 2, or if it's just too long and tidy, we can just say assignment question 2. And our model time units is months, and all we have to do is finish here. So I'll also uh, go back to the view options here because some of the students in the classroom could not find this. So for example, say I lose this, or say um, I lose this, say I lose the properties tab. So I'm supposed to see properties for every variable when I click it. Yes, so if by any chance you don't have anything and you just have this, you can play with your views, and if even if I don't have this, for example, or the palette here, so that we can build it from scratch. You can either restore this, or you can say view. You can let me see my projects, and then you say view and let me see my palette. Palette is the one next to this one, and what we're left with is the console view here, and the properties view here, right? So we just have to do console here. The trick is, um, unless you save your specific views, um, it will just be that you have to keep dragging and dropping. So let's just maximize it. Sorry, I'm trying to find my console view. Let me start with the palette first. No, I'm sorry, properties first. So here I have my properties. Um, and now let me see my console. It should show, yes. So this is the basically what you should expect to work with. uh, all right, so let's go back to our model, and you can see your models here. So this is what we created, it's empty. um, so when you come here, you start with the main. So this should be where you work to create um, your work. So, and one more thing here. So when you do your run, if you just hit run if you don't select the specific simulation where your model exists, it may be hard to find your specific model. So let me go to my blank model, and if you don't see it here, it's just because it's taking it here. I can bring it next to my main here. So this is the uh, empty space now we're going to work with. So anytime you start your modeling, we go to the System Dynamics tab here and we click it. So these are the features we'll work with. So you have your stocks, you have your flows, you have different variables, you can even have parameters. You can have, I've shown you the shadow functions. We can see it here. So for example, if I have a certain set of relationships here, and if I want to keep it tidy and neat, I can have shadows of different variables here. So if I select the shadow of dynamic variable one, it will just be that whatever values I have here will be here. And instead of, say for example, if I want to relate this one um, to this one, instead of doing this and affecting my it's more of aesthetics but also convenience as well, so I can just do it here like this. Oh, sorry, I have to draw it from here to here, sorry. So yeah, and you can move your naming like this if you drag it, so just keep like experimenting with the different stuff, so that way it will look more purposeful. So now we have this. Let's go back to this model and enter the values for each specific um, a variable, so and relationship. So yeah, I can come here. I know it's the second model. If you come here, I know it's my first model. So you don't, if you get confused, you just have to click it here, or even you can name your main agent. So you can say question two. So that way, this is what we're working with, and it's showing you red because uh, it's facing some problems. So this way, so you know that your model is in trouble. So if it's showing you red, I can do it through two things. One, I can go here, keep following the red and find my problem. My problem is here, so it's telling me different things. So parameter not used but expected. So it's, I can double click it and go to the variable. So because I'm using it as a function of the parameter, it's telling me that I need to use something here. Instead of zero, I need to give it in a way that relates to what I attached it to. So now you won't have anything here. So let's very quickly go and fill up the models variables with what we have. So instead of going back switching between two models, what I'll do is I'll just can close it and open it again. It won't be a problem. So for the number of workers, for example, I can do here and I can do here. So this is how you would start your models, right? So here I have number of workers, and this one is initial product. Now it's going to be a little bit tricky um, because they're both in the same model. It will not allow me to use the same variable name for two different dynamic variables. So for the sake of argument, I'll just keep adding number one to it. So that way we will just see how we're doing um, the dynamic modeling, and then we won't worry about the naming. So number of workers. If I do one, it will allow me to write it, right? So, and here, initial productivity. So the main purpose of this tutorial is to show you how you can populate your system dynamics model with variables, with stock and flow diagrams, and with all the necessary relationships to execute the model, right? So I'll just use a different name so that we will not uh, um, take too much time in trying to copy and write relationships from the PowerPoint. So basically, the value for this is 4 that you guys were given. This initial productivity was 1, and the potential work rate is number of workers times initial productivity. However, when I come and write it here, what I'm gonna do is, because I am using a different variable, what I do is I'll just select this and name it here. Sorry, I used copy again. So I'll use this and paste it. I'll use this and times paste it, and I won't have any errors. Should be good. Yeah, so, and this is potential work rate. This is my potential work rate, but again, I'll keep renaming it. So you'll do this in a clean and empty sheet, so you won't have any problems here. So I'll keep creating the dynamic variables like this. So now when we come to the stock, so please try to make it a little bit bigger so that way you can see it, and you can put it inside, you can put it outside, you can color it differently. You can start with yellow or green, and what to do. So sorry, work to do, we'll just keep 1. So once you do this, it's usually tricky to connect these dots if you don't create a hinge for it. You can draw your loops. I'm sorry, you can draw your flows by using this. For example, if you click this, all you have to do is, sorry, all you have to do is click, 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 and click. This is just to show you, so I'll need another stock to complete what I want to do. So I'll just very quickly rename this. This is undiscovered work, but I'll just put 1 on it, and make it tidy whenever you're doing your model. And I can just do control and then drag it to create another stock instead of going back all the way here. And here, this is, and you can also select it and then keep dragging it down, select it, drag it down. That way it won't affect whatever you're working here. So here we can rename it as work done. So now, oh wait, sorry, it didn't rename it because I forgot to give it a different name. So now let's draw our flows. So just double click it and then 1 click, second click. This is my flow. I'll rename it later. And then come here again, double click, 1 click, then you create a hinge for it here, 2 click, 3 click, and then the 4th. I know it's not looking pretty, so what we can do is just kind of drag it and make it perpendicular. And flow, it's a bit tricky to adjust, so make sure you go exactly to the circle point here and then keep dragging it here. And let's come and then keep keep dragging her here. So when this happens, what you can do is, I'll create a hinge for it here, double click, and then drag the hinge all the way here, so that way you have your flow. And then the same thing here, double click, sorry, double click, and then click, 1 click, 2 click, and 3 click, and again I'll just drag it to make it perpendicular. So you have your flow variables. Now, uh, the work to do to work done. So this is my potential work rate, right? So let me just keep dragging this here. Oh, sorry. Let me drag it here. Okay, so this is my potential work rate. So I have to connect this to here. And then what happens is this is the rate for the transition from work to do to work done. So I'm just going to change it here. So you won't see the problem, the red problem here. So this is one, and my quality for now is um, the variable that gives me the function, no, the effect of quality of work on the total amount of work to be done. So this gets fed double click, sorry, one click, double click, and just go here. And this is my flow, right? So potential work rate one, times quality one. All right, so this is my work accomplishment. So I rename it one. So, and I keep, you click it and then drag it here. So that way it won't have a aesthetics problem for you guys. Okay, and now the other one is the relationship between how what's the rate for rework generation uh, and um, and how do we go about this. So this rework generation is a function of the quality and uh, by what rate is this work going out. So if had it been that the given task that was completed, if it didn't have problems, then it would go exactly to here, right? But when it goes out, instead of going out here, it's going out here, right? So with the same work rate, instead of it going here, it goes here. So that's why we're going to use the same productivity for the flow rate, but as a function of quality, right? But instead of directly, and one more thing, make sure you connect the dots, I mean the links. So if you don't connect the links, it won't show here. So if you click this variable, if this two links are active, right? But say if I don't connect it just a little bit here, now this thing is not connected. This variable is not connected with this link, right? So if I click it here, the only link it's showing me that's connected is this. So I have to drag it here. Sorry, I have to drag it here. Have to, okay, go away. Have to drag this link here and put it here. So there's some tidying up that needs to go on, and if you want to click it, you can't see it here, so you have to click the variable that it's corresponding to and then drag it from there. Okay, so this is 1 minus quality times the potential work rate. So instead of copying it, this is just formula. So I'm just gonna do this, and my naming is different, so I'm just gonna do this. So here, this is one, and this is the rework discovery, which we designated as 4. I'm sorry, time to discover rework is 4. Rework discovery is the flow rate, and the flow rate, which is uh, described using this the amount of undiscovered rework existing in the stock, and the time to discover rework. So uh, we'll copy this formula here. Um, and again, I am copying this so that I will not waste time in going back to the PowerPoint and then writing everything from the PowerPoint into this when I'm doing the formula. So this says rework discovery, and I have one. Now I'll show you something here that is, let me first uh, do this one. So now if I do this, let me just copy this formula, and like general misconception, I already did, sorry. General misconception is, now you see, for this rate, we have this and this as a function, right? But when you go to this formula, it's still showing you error, right? Because undiscovered rework one is used but not expected. See it, even though this connects it, even though this arrow connect kind of goes through this flow rate, it is actually not recognizing it as part of the function. So to do that, you still have to draw a link that connects your stock to the flow rate. Sorry, I used undo. So now it should be good. Time to discover rework one is not used but expected. Um, let me go to the formula here. Oh, sorry, this is too much ones here. Let me delete this. See, that's what I did. I wanted to show you the error coming specifically from from this undiscovered rework. So you see, it shows you undiscovered rework one is used but not expected. It's telling you it's in this equation, but I don't have any means to expect it. So go back, take it here, and now we won't see that it should be gone. Undiscovered rework, or maybe we didn't connect the link properly. Okay, now it should be gone. Undiscovered rework one is used but not expected. So now it means we don't have it in this formula. Let's copy it and paste it here. Okay, let me see what's the problem here. Undiscovered rework one is used but not expected. I'm just gonna check if it's part of the formula here. It is part of the formula. It's undiscovered rework divided by time to discover rework. So this one, which is rework discovery, let me rename it first, is undiscovered rework 1 divided by time to discover. Yeah, maybe it's just taking its time while it's removing the error. Okay, so now this is the model. This is the model, so all we have to do is run it. Initial value, you always have to give this an initial value. That's 100. But also, in this case, it's not only 100. You have to have the rework discovery, right? So if you click it here, yeah, so we're now here. Sorry, we're here at work to do. So initially you have 100. um, you can in the lecture note, it says initial is 100, but there's also rework discovery, which is in addition to the 100, the people are also working extra because of the rework that is being discovered on a monthly basis. So we have, if you see the equation mode, you have um, I have put it as this previously, but now in the equation underneath you have here that rework discovery is rework discovery 1, which is the rate at which every month an amount of rework is being fed into this stock, and from this some amount will leak here and some amount will go here. So work accomplishment and rework generation, they are supposed to be negative values, and this one will have extra value as positive because of extra rework amount coming into it. So coming into the work done initial value is 0, but every time step, uh, it will have work some amount of work based on the work accomplishment that gets fed into this stock variable. And the same goes here for undiscovered work. Rework generation comes in, and then rework discovery goes out. So this is how it depletes. This is how it accumulates based on the rework generation. All right, so I think we're set. We're set. The neat thing about this is you can run both models together. So I'll just go and run it, but due diligence first. You have to build it first, right? That way, if you have errors, if you have several types of problems, you can go fix it. So always make sure you build it, and when you build it, the nice part about it is it will give you several options to run. So here, if you go here, this is where you run it, right? This is where you kind of pick your steps. But here, if you see the three dots, you have run options. So run until, if you can put a calendar on it, or run for how many times, or how many situations. And I'd like you to experiment on uh, triggering a stop when the stock depletes to 0, gets to 0 or almost to 0. Um, but if you tell it to run forever, it will keep running forever, even though it achieves equilibrium. You will have to go here and hit the stop button to get your results. So let's run it. Now I'm only seeing one, but if you zoom it out just a little bit, you can see both. And what you can see here is for the times horizon that's selected, the work to do is now 43. It's it will keep going if we extend the time zone. I mean the time, if you stretch the time for the simulation. You can look here. This is how much is done, but you have to look at the time here. It's over 40 months, almost 50 months, and we're still like 45% of the work is done. And that is because every time a work is done, rework keeps happening. So undiscovered rework at this instant was this much. So it's like every time instant we're discovering work to be performed. And yeah, let's change one more time, stretch the time, change the quality, and see this once again. Let me stop it. I think I can close this, go here, change these two variables. I can make this 0.75, and for you guys to compare it, you can make this 0.25. Again, I won't change it. Simulation, let's put a stop time of 60 months. Yep, let's run it now. No, build it, sorry. That way I want to slow down the time so that when it runs, I'm able to capture how it's progressing. Okay. Okay, so let's build it, and let's go here, and let's change the time to, let's slow it down like 1/10. So if you can see here, you can click the graph and see how it develops. See the graph and see how it develops. So this one is with a higher quality, 0.75, and this is 0.25, right? So you can see how the works are being progressed. So I'll put this next to each other. That way you can see it. Let me pause it and let's create a better picture for us to compare it with. Bring it here. Bring it here. Work to do. With work to do, sorry. Let's put similar items that we're comparing together. That way we can see the differences. See here, it's going right now it's okay, but we can somehow see the difference in real time as time progresses. So let me put undiscovered rework of this one here. Put it just beneath here, and I have undiscovered rework, I have work to do, and work done. These two I can compare here and here. All right, sorry. So let's keep running it. Let me plug in my battery, sorry. So now let's just speed it up just a little bit, and let's see how it changes. Oh no. Oh shoot. Okay. It's not listening to me, so I'll just do it here as it's running. So you can see, hopefully, how it's changing. So in here, it's the 6th day. Still okay, but here you can see a lot of undiscovered rework. It's 10. See, it's just 3.5. That has an impact on the depletion of the work to do. It's 60 here, but it's still like 80 here, right? And the work done is also, it's still small. It's 30-ish, and here it is, no, sorry, this is big compared with this. So this is still 10, and this is 30. So I'm gonna push the model just a little bit faster and a little bit faster. So I want you to look at how it's changing, right? So it's like 57, 58, 19, 20. So now when you speed it up into real time, now you see the undiscovered rework is not that big compared to this one. So I'm gonna make it faster. So here, so throughout the time, uh, still not a lot work to do. I mean, still like 50% of the work to do remains. This is like going downwards now. So undiscovered rework, we still have just a little bit, but we have 11 here. So yeah, basically this is how you do your simulation, and it all goes down to making a meaning out of it. So what does this mean? So in this specific case, we can say something about the quality, and then now in your assignment you also have an option to change these variables, say time to discover rework. So if it takes longer to discover rework, so how does that impact our model? Changing different things, and perhaps for your own curiosity, I can argue that this is not your regular typical system dynamics, because it does not have a closed loop. That means you cannot actually see reinforcing and balancing loops here. And that's only because uh, we wanted to make the model very, very simple for you. And having that reinforcing balancing introduced into this model would make it a bit complicated. But now at least you have some idea of how the dynamics is stemming from how they change in different variables as the stock depletes, um, and then another stock gets accumulated. So that difference and how this complexity arises based on just these three or four different variables. So uh, this is just the beginning, so that you have it as a springboard to explore and make it your own adventure. Yeah, thanks very much. That concludes the whole tutorial session.